So I imagine a few more people will pop in as we begin, but yeah, we'll get started. We've got quite a few slides to go through. So what I would say is, if you've got any questions, I'll open up the sort of forum at the end of the session, and then we can have a good run through any questions for everybody's benefit. So I'll get going with the presentation. So good afternoon, everybody. I'm Carl Lycett. I'm the Rittal UK Product Manager for Climate Control on both the industrial and the IT side of the business, which, as you'll learn in this presentation, are two different things. This presentation pertains to industrial, the fundamentals and sort of the basic knowledge that we think everybody should have as to how they should utilize climate control in a correct manner. So hopefully you'll all get some nuggets of wisdom out of this. Obviously, I can see, you can't see, but I can see all the attendee numbers, and it's a really healthy turnout today. So thank you all for being here again. Obviously, everybody's getting bored already on the coronavirus if you're all signing up for my presentation, but I will take what I can get. So let's get stuck in. Right, so in this presentation, what I'm going to cover are the following topics. I'm going to cover the role of climate control when it works with enclosures, the reasons for our equipment failing and the costs of ignoring the symptoms of poor climate control, how we evaluate and understand what climate control is required, the types and the suitability of different climate control offerings that we have. I'll have a quick touch on specific industry sectors and just certain considerations you might need to make dependent on the product you make or industry you work in. The importance of installing correctly to the manufacturer's instructions. And finally, a pretty much missed topic in a lot of instances, which is how important it is to service and maintain the equipment over a long period of time, because that really does pay dividends. So yeah, let's get stuck in. Right, so we'll start with the role of climate control. And as I've mentioned here, it's an important consideration in 9 out of 10 installations it's going to be required. Right, so what is the role of climate control? Well, if we take a definition, it works in conjunction with an enclosure to create a protective environment for the installed equipment. Now, my job is to look after climate control. Your job is to run a factory, much like what you can see on the screen, maybe make bread. You're a panel builder. You might sell products that pertain and require climate control. We understand here at Rittal that your concern is not our products. We're here to be the expert of our products and help you create that protective environment. Your worries, your concerns are keeping your factory running, keeping downtime to a minimum, and that's where we can help. Okay, so we start off with our enclosure, preferably Rittal. And what we're trying to do with our climate control is maintain an enclosure internal temperature, also known as your set point. So this is your temperature inside the enclosure that's going to ensure that your equipment is happy, okay? And climate control is going to protect from 4 things. It's going to protect from high temperatures, low temperatures. We always think of high temperature for cooling, but low temperatures are dangerous as well. Condensate or moisture, because obviously we don't want that. We don't want that inside the enclosure. And then finally, dust, dirt, and corrosive substances, because regardless of where you're working, there's going to be some level of dust or dirt or debris in the air, and we need to stop that going inside the enclosure and attacking that all-important critical equipment that's running your factory or installation. Now then, so if we look at this report here that was done by the US Air Force and their integrity program, they've broken down the reasons for electrical equipment failure into 4 slices of the pie in their report. So we have vibration, moisture, dust, and temperature. If we look at these 3 that are highlighted now, we can reduce or fully address 80% of the electrical equipment failures by using the appropriate climate control solution. Not a climate control solution, the correct climate control solution. There is a difference between the 2. So I'm going to go into that now. I'm going to go into these 3 slices in a bit more detail, and why we need to combat them and what happens if we don't. Okay, start with temperature, which is the main one that we tend to talk about. So we have a sealed enclosure. We put a nice large electrical drive, PLC, transformer, whatever, pick your poison inside of the enclosure, and that emits heat. We then move into, as we are doing now, into higher ambient temperatures outside. Starting to see the t-shirts come out and people feeling the warmth. Obviously, all this warms up the warehouse, the factory where you're working. So you add that to the heat output from your enclosure, from your equipment, and we get a high internal temperature, which is obviously what we don't want. Now, a point on this, especially in the UK, some people seem to think that there's no such thing as a high ambient temperature because, as we all know, the stereotype is it's always cold and rainy in the UK. Now, you might not see high ambient temperatures. You might work in, high end of Scotland. It might be freezing all the time. It might be snowy. It might be rainy. That's fine. That doesn't mean that there isn't enough heat being generated by your equipment to create high temperatures inside your enclosures that could damage the equipment. And on the flip side, you might only have some switchgear or some PLCs in there which don't really kick out much heat. However, it might be just really hot in your warehouse, your workshop, because you've got so much equipment crammed into a small space and you've got a poor level of HVAC equipment. I see this all the time when I used to visit sites when we could, and obviously will do in the future. So these two factors can occur together, which obviously makes it even worse, or they can operate separately. So always keep them in mind. Don't just sort of think, oh, pish tosh, that doesn't apply to me, because in 9 cases out of 10, it will. Okay, so the first reason we don't want high temperatures is because that equates to reduced performance. So this is a performance chart I took from a Schneider drive, no particular reason, just something I found online. And as you can see across the bottom, we have the switching frequency, and up the side, we have the drive current. And we've got 3 lines on here in the different colors, and these colors are the ambient temperatures at which the drive is performing in. So this is your internal temperature inside your enclosure. So as you can see, the drive starts maybe at worst case scenario with 60 degrees C. Okay, when we look at 60 degrees C, even when we're at 0 switching frequency, that drive cannot hit 100% output. And as we all know, when you're designing an enclosure or putting a drive in or speccing a new drive and you're buying it from a supplier, you're going to want it to work at 100% at some point. It might be the axis for one of your, one of your robot arms or picking machines or some sort of machining center. If it can't work to 100%, you're already hamstrung before you even begin. So again, let's take the temperature down. So we look at the 50 degrees or we look at the 40 degrees, and it's a bit cooler inside the enclosure. Still not where we want it to be, which is 35 degrees C. That's the industry standard that we like to try and maintain inside the enclosure for industrial equipment. We'll speak about that a little bit more as we go on. But even if we look at the 40 degrees C, which is the pink line, the bright pink line, it can run at 100% during those low switching cycles. But as it sort of ramps up and it's starting to be asked to do some proper work, 8 kilohertz and above, it slowly or very quickly drops off and falls into the 60% range. So what that's telling us is these high internal temperatures are going to prevent your equipment from working to the output potential that you need it to get optimum performance out of your equipment. What that will result in, and I've spoken to engineers in the past where they've said, oh yeah, we know our climate control is rubbish, but what we do is we just buy a bigger drive. Now, that's great for the drive companies because you've just spent $5,000 extra on the drive up because you know it's going to derate when you install it in this hot environment. But that's coming off your bottom line. That's coming off your budget for this year. Whereas if you installed the right climate control or maybe did a bit of a jig around inside the enclosure and got some better airflow, you could save some money. That could be used on something else, another drive you might need, or other improvements on a shutdown. So it's just using your head and spending that money wisely. Okay, so we've got reduced performance. Now we've got reduced life. Okay, so based on this curve, this Arrhenius equation curve, which looks at the life and performance of equipment, And we do see this quite often, if we take an enclosure set point or internal temperature of 70 degrees C, you could find your equipment maybe having a maximum lifespan of 1 year, which is no good. You don't want to be, you don't want to be spending and replacing equipment every year because it's going bang every time summer comes or every time you ramp up your production. If we're a bit more sensible, and as we mentioned, we take it back to that 35 degrees that we like to try and maintain as per the standards, we could see a tenfold increase in the life of our equipment. And that just makes a lot of sense because, again, we're going back to, if you're a maintenance guy listening to this, it's less work for you. You can be working on bigger things that are more important rather than having to fix random breakdowns on a line. So it's using your head and improving things in the right manner. Okay, so these temperature issues add up, and this is the sort of storyline. It's not a very fun storyline. I'm pretty much doom and gloom all the time, but sadly, that's just where the job takes me. But this is the storyline that I tend to talk to people about. So we have those high internal temperatures for a prolonged period of time. That then in turn becomes reduced performance and a reduced life of the electrical components. That's what we've just covered. But that then leads to increased maintenance needs and unplanned breakdowns. Now, the increased maintenance needs, a lot of these companies that I visit, the maintenance guys are flat out anyway, because you're all working on, preparing for shutdowns or random things have gone bang and need replacing. You don't want another enclosure on your list to fix. You want to be as, slick as possible and working on the most important thing. And an unplanned breakdown, obviously, is just no good. But this then is going to take it's going to reduce your production output and the overall efficiency of the plant. And I hate, I'm not trying to coin a phrase on what's happening at the moment, but as we know, food and beverage plants, or, it seems like toilet paper manufacturers, all these people that are making things that people are panic buying or requiring at a much bigger level at the moment, they'll be working at a higher production output than normal. So an unplanned breakdown for a site like that is horrendous at this point in time. And all that is going to add up to increased costs and also loss of profit, which, as an engineer might not be your concern, loss of profit, but your managers, people above who are looking at the organization from a higher level, loss of profit, and money straight off that bottom line is a no-go, because we're always trying to reduce costs, improve profits, get efficiency to 99.9% if we can. Now then, let's move on to dust and debris. So regardless of the industry, your ambient air will be contaminated in some way, whether that's just dust, which you even get in an office space. It could be oil, it could be, cutting fluid if you're using machines, lathes and stuff like that with cutting oils, tapping fluids. It could also be, if it's a bakery or some sort of chemical environment, it could be yeast or chemical extracts in the air. They are surprisingly aggressive and will attack wiring, will attack metal and things like that. Therefore, what we ask is you need to choose a suitable solution for the environment that you're working in. So you need to appraise your environment and choose suitably. Now, the thing we tend to hear in our industry quite a lot, the typical catchphrase is, chuck a fan on it, that'll be all right. Fans, you get one from RS, get one from wherever, and everybody thinks, oh, that'll be okay, because a lot of people think of equipment as they do a person. But you need to remember, we're not cooling a person here. A bit of a breeze from a fan might make you feel good, but it's not going to work on your 10 grand, 100 grand's worth of drives inside your enclosure. So fans and filters do have a worth. They have a place where they work correctly, but you need to use them in the right manner. So if you are using air cooling, you are using fans and filters, you need to be installing filter mats, because that will reduce the amount of large debris that gets inside the enclosure, okay? Because a fan and a filter is constantly pulling in, as you can see from this diagram here on the bottom right, it's constantly pulling in cold air at the bottom and then spitting hot air out at the top. I don't know if this will work. Let me give my little spotlight a go. I don't know if you can see my spotlight. But yeah, so the cold air is coming in the bottom, and then the hot air is retreating out the top, and this just continues, and debris is going to constantly come in and out of your enclosure. However, if it is a very aggressive or dirty environment, air cooling, fans and filters are a no-go. You don't want to be doing it. If your place looks like the picture in the top right-hand corner, don't even think about it. You want to be working with a different type of product which has a separate internal cooling circuit. Now, basically, all that means is the cold air is pulled over a coil, much like the diagram in the bottom right-hand corner. It's pulled over a coil, and the internal air is also pulled over that coil, and the heat is transferred from inside the enclosure to out. However, the two air streams never cross paths, so you're not getting that constant barrage of dirty air coming inside the enclosure. Once the door is shut, hopefully that your enclosure is sealed correctly, you are not constantly seeing lots of dirty air coming inside the enclosure. So that is the better way of doing things. Okay. Right. Next, condensate. So moisture inside an enclosure, it's going to damage your electrical components, and frankly, if this is something that's left untreated and begins to build up, it's a safety risk. I'm no electrical engineer, but I know that water and electrics don't really mix together very well, so we need to try and prevent that. Okay. Excuse me. So preventative measures: maintain the integrity of your enclosure and keep the doors closed. Now, this sounds silly, but this advice is here from things we've witnessed as our experience as Rittal. A poorly sealed enclosure results in ambient air constantly leaking inside the enclosure. So you're trying to cool the whole factory. Again, going back to our human example, if you're driving down the motorway, you've got your aircon on full whack, and you open up the window, you're not going to feel the benefit. It's not going to be able to do its job. And frankly, you're going to start damaging the equipment because it's going to just have to work harder and harder. Another thing is that regular opening of the doors, or the doors not closing correctly. This is an issue because it's another leak path for equipment to get inside. And again, if you're exporting your equipment to a final customer, for example, abroad, where it is high humidity in the Asias and things like that, it's even more important that you stop that highly humid air getting inside the enclosure. So this is where we recommend you using, if it's an old enclosure you've had on site for years, you need to make sure that it shuts correctly or get the doors replaced, or you need to use the door switches that we sell. They link to the cooling unit, so when you open the door, it turns the cooling off. That protects it. It's it's not like it's preventing the cooling unit from just running and burning itself out. Okay, so that's something to keep in mind. Very low cost item, can save expensive repairs or accidental breakdowns further down the line. Now the next one: correctly size equipment. So if there's cooling equipment on there, how did you size it? Did you just hit and hope, buy something off somebody's website and think, that'll be okay? Because frankly, that's not going to work. You might oversize it and you might be okay, but again, you might be wasting money or energy there. The best thing to do, is size it correctly, because otherwise, if it's undersized, it's going to be working at 100% output all the time to try and pull that temperature down to 35 degrees C, and it's never going to be able to do it. All that's going to happen is your equipment inside is constantly going to be too hot. Also, the lifetime of your equipment, i.e. the cooling unit you've purchased, it's just going to run and run and run. It's like over revving your car. You're going to damage the car, you're going to damage the cooling unit, and it will go bang. And then you've got no cooling at all, and you're back where you started with lots of issues. You may say to me, well, we size all our cooling correctly. You may do, and that's great. I applaud you for that. Well done. However, one thing to keep in mind is, and I know what you like, you like to buy new equipment, but you like to sneak in an existing enclosure. You might have a space for a little transformer, or you do a line upgrade and you whack them with a couple of PLCs or drives in an enclosure that you've got on the side of a line. Great. But the problem is, all of a sudden, 2 years ago, when you did your thermal calcs, your equipment was great. But now it's undersized again because you've put too much equipment in. So what you need to do then is you might need to buy another cooling unit, a smaller one, to work with your existing equipment, or you might need to rip all your cooling units out and increase to a larger one, depending on how much upgrades you've done. So again, just something to keep in mind. Okay, so now we need to prescribe the correct climate control and listen to what our plant is telling us when we're on site. So some of the main signs when you're walking around a site, whoever you are, some of the signs that you might see that's going to tell you, oh, some cooling is needed on this site. Number one, sounds very odd, but give that enclosure a touch. Just put your hand on it. If it's warm, that's going to mean that chances are when you open that door, there's a lot of equipment behind that steel door because, and you've not got adequate cooling. Because if you have adequate cooling, the steel would never have chance to get warm because the heat would be eradicated before it dissipated through the steel door or the steel wall. So touch it. If it's warm, chances are you're not cooling enough, and the set point, the 35 degrees, is not being maintained inside the enclosure. On the flip side, if somebody's turned the cooling unit down to 20 degrees, thinking it's a human the cooling, which again is a no-no because you're wasting energy, the enclosure sometimes can be cold, which again tells you the opposite. Oh, hang on, maybe I'm cooling too much here and I'm wasting energy and I'm burning pound notes. So you need to think about it in both manners. Next, we mentioned this earlier, but high ambient temperatures. If you're walking around site, around Christmas time and you're sweating, or you're walking around in a t-shirt, which again I've done when we've done site visits, think about how your poor equipment's going to be, because if it's hot at the coldest time of the year inside your warehouse or your workshop, then when summer hits, you guys are going to go into meltdown, which is what you don't want. So the best time to try and eradicate or mitigate these issues is during the coldest part of the year, or now. We're in spring, we know it's going to be getting just warmer, so don't put it off. We all like to put things off, but the best thing to do is nip it in the bud now, and you won't have those issues come summer. Next one. If a lot of people do this, but if you have your doors open to try and mitigate some of that heat, because you keep getting your drives clicking out on overheating, or you've got fans blowing on your equipment because nothing else is fixing, I'm secretly judging you. That's something, frankly, all you're doing there is allowing dirt, debris to fly inside your enclosure. It's going to be attacking all your wiring, getting in your connections, and it's going to be pulling down and reducing the performance and the lifespan of your equipment. So it will not pay in the long run. Also, not to mention that this is a massive health and safety risk. And I'm sure, if your health and safety guy got wind of this, he probably wouldn't approve of it. Even if you put the infamous black and yellow tape across the door, that's not going to stop somebody falling in and or touching something they shouldn't, and they might not get a second chance to know about it. So yeah, let's try and keep that to a minimum if we can. Next one, large drives. They tend to come with high heat loads. As a rule of thumb, and this is very much a generic rule of thumb, so it's not an official thing, but we tend to work on 3% of a drive's output is lost as heat. However, normally on most drive manufacturers, they will provide that an official figure based on in their installation manual. But as a rule of thumb, when you're first looking and appraising, if you've got 5 drives in there that are 100 kilowatts, all of a sudden, you've got a fair bit of heat to deal with inside your enclosure. Okay, so components being replaced regularly. Again, as I mentioned on one of the previous slides, if you've got, every year your spares budget is through the roof. I once went to a site and an engineer said to me that they spent on one enclosure, they had about 100 grand's worth of kit inside this enclosure, and they replaced 10 grand a year in spares on this one enclosure. It was a large panel, don't get me wrong, but 10 grand a year is a lot for spares. Something was going wrong here, and it was, in this picture as well, this is a factual picture taken by one of our service guys when he's been on site. So again, just have a think about it. If there's any sort of, if there's any ghosts or bugs in the machine, particular enclosures that give you jip every year and they keep, dropping in and out, and you have to replace boards and things like that. Cooling might be your answer. And the final one is obviously appraising your environment. If it's aggressive, if you're a foundry or you work in, I don't know, a chemical environment where you've got raw or chemicals in the air, that could be aggressive. These are the sort of things that you need to keep in mind. So just have a look around you and think, does this seem, slightly unusual what we do? Are we a foundry? Are we a bakery? I don't know, do we work in molten plastic injection or something like that where there's a lot of heat? Possibly need to appraise my cooling. So you've got a gut feeling now. You want to go to your boss and say, maybe we want to fix this, but you need to prove it. So you need to confirm your suspicions. So the first one, this is a really great way to have something physical that you can, keep going back to. It's our infamous Rittal thermal labels. So these guys, you stick them on the inside of your enclosure, on the door, preferably on the inside, guys, not on the outside. We have seen people use them wrong. Stick them on the inside, and what happens is those little squares on the blue strip on the left-hand side, they will, if they see that temperature, which starts at 37 degrees Celsius, they will black out, they will sort of blow out because there's chemicals in there, and they will stay blacked out forever. So what you can do is you can slap them on the inside of your enclosure door, leave it for a few days, and then keep coming back to it and think, oh, God, since I've been away, it's got to 43 degrees inside my enclosure, and all of a sudden, you've proven your point, and you can give us a ring or give your distributor a ring, and we can come in and help you in a bit more detail. So if you do want some of those, they are available to send to you. So all I would recommend is sending an email to the email address you can see on the screen, cooling@rittal.co.uk, name, company, address, all that normal information, and we'll get some sent across to you. Yeah, they're a nice little tool, those really are. Next thing, as part of our Reassure package, which is a package where Rittal will visit site for do an initial appraisal of your site for free. If we come to site and we believe you have a case and you require more detailed analysis, we can do paid inspections where we'll go more into a deep dive and do thermal logging, where we'll put temperature loggers inside your enclosures and outside. And we can also, if need be, do thermographic photography if there's hot spots in certain cabinets. That is a paid service, but it's one of those things that we can come in for free. One of our sales guys will come in, they've all been trained, and they will do an initial appraisal of your site and give you advice and discuss with you the best solutions. And from there, they'll work on the best step forward to improve your efficiency of your site. Now then, so we've now proved it, and we need to calculate what level of cooling we require. This is where our Therm software comes in. So our Therm software is available for free. You can download it from our website. You can either access it as through your browser, or you can download it directly onto your computer as sort of an app or a little bit of software. And as you can see from the screen, the sort of screenshots I've got here, it's very, very simple. All you do is you put sort of the size and location of your enclosures, how much heat is inside, and then the software will automatically just tell you what it recommends. So this example I can see on the screen, it's saying there's a kilowatt of heat inside. So it's going to be, without any cooling, about 79 degrees inside at worst case scenario. So what will happen then is you can then click on the little cooling unit button, and it will tell you which cooling units will meet the needs of the cooling that's required in that enclosure. You can then print that off as a PDF. That's then something physical you've got that you can maybe hand on to a final customer if you're a panel builder, or you can keep that in your records and say, right, on this date we did this therm calc and it said we needed this, so we know we've done the right sort of cooling. Now then, this can also link to our ePlan software. So if there's any ePlan users out there, if you do design panels in a bit more detail, ePlan links directly with Therm inside of the ePlan software. So it pulls you into Therm, you do your calc, then it takes you back into ePlan, and you can have a 3D digital representation of the equipment, and you can do the design if it's a brand new panel build without even putting, cutting any steel. So that's a great way to get the panel designed and perfect straight off the bat. The other thing we have got for Therm is the Rittal Therm questionnaire. I would really recommend you all maybe try and get a copy of this. And the best way to do that would be to send an email to cooling@rittal.co.uk or contact your local area sales manager if you know who that is, and we'll send you this PDF. And basically it asks you or gives you a hint of all the details you require to then fill out a correct Therm questionnaire. So it's a prompt. So if you're talking to an end user and maybe they're abroad and they're like, oh, we need cooling, it's going, in the middle of the desert or something like that, somewhere really hot, you can say, right, what's the max ambient temperature? How much heat loss of their equipment is there? Is there a specific voltage? Is it, is it 230 or is it going to America? So it's slightly different. This is a good prompt just to keep by your side, and whenever you're speccing up an enclosure and doing a Therm calc, you can have a tip of what gear and what equipment and what information you need at your side. Yeah, and there's the email address. So if you need a copy of that, just ping an email to cooling@rittal.co.uk and I'll happily send you a PDF copy of that over. And yeah, that'll be a little useful tool for you. Okay, so prescribing the correct climate control. So we've when we're in the software, as I mentioned, the Therm software will tell you these types of cooling will work. However, it's good to have a bit of knowledge from yourself as to why you would choose one or over the other. So I'll just go into the types of cooling and climate control that Rittal offer, because we break it down into 4 sections. So climate control is broken into air cooling, which is fans and filters, or our air-to-air heat exchangers. We then have our cooling units. So this is where you're doing more active cooling and you're bringing in a refrigerant circuit. We then have heaters, because that's for our low temperatures, because again, low temperatures are just as bad as high. And then we have liquid cooling. So again, it's cooling in the same manner as a cooling unit, but instead of a refrigerant circuit, we're using chilled water. So I'll just go into these in a bit more detail. However, I could do probably a webinar on each of these bubbles, which I might do in the future if it's of interest to everybody. Let me know in the chat. So air cooling. So the thing about air cooling, and this is something, again, I mentioned sort of early on in the presentation, chucking a fan on it, which seems like a good thing to do, is not the solution in most instances. And the reason for that is because air cooling can only transfer energy from the inside of the enclosure to outside. If it's hotter in your ambient environment, so say it's 45 degrees in the ambient environment and you want to maintain 35 degrees inside, it's never going to happen with a fan and filter. It's like opening the window on a hot day and expecting it to be cool inside. It's not going to happen. So you just need to keep that in mind. So that's the first sort of rule of thumb. Now, our fans and filter units look like the following pictures. So we've got the wall mounted, as we call them, fans and filters. So we normally locate the fan really low down, as you can see from the little picture. And the filter then is an open grill at the top, which allows the convected air, which is obviously heated up as it's gone over the equipment, to be lost out of the enclosure. However, which are quite nice, we have our roof mounted fans as well. The roof mounted fans, as you can imagine, sit on the roof plate, and then you have a filter mounted at the bottom of the enclosure. And what happens is the roof fan is then sucking upwards and pulling the air up through the enclosure, and then it's exhausting out the top. The good thing about a roof mounted fan is the fact that if you've got switches and stops and buttons and dials all over your enclosures, you can still get some cooling on there by putting it on the top. So that's a nice little solution. we also have air-to-air heat exchangers. Now, the good thing about an air-to-air heat exchanger is it still utilizes that difference between internal and external temperature. However, it's a separate internal air circuit. So what's happening is it still acts like a fan and filter, but it's not constantly pulling dirty air inside the enclosure. So if you know you have a dirty environment, but it's cool enough to use air cooling, your air-to-air heat exchanger might be your man. Okay, so keep that in mind. It can be a nice handy solution for you. Now, both of these, like the fans and filters, they are much like a desk fan. They are a dumb piece of equipment. You put power on them and they will run forever at 100% until they are told to stop. That is where the control accessories come in. These guys are inexpensive, but will save you a lot of energy, which is very important at the moment. You know, most of you guys, wherever you work, you will have energy managers or people trying to reduce energy or increase energy efficiency, reduce the footprint of the business because of government legislation, etc. It sounds stupid, but if you've got a bank of large fans running all weekend when no equipment's actually working, that's a lot of money, being burnt in electricity. So things like a thermostat, which obviously you turn the dial and select your selected set point, and then it will click the fans in and out when needed. The hygrostat, that does the same thing, but it looks at the humidity. So if humidity is of particular sensitivity for you, hygrostat is your man. And then the speed controller. Now this is sort of a bit more advanced. So it's much like a hygrostat, like a thermostat, sorry. However, it also allows you to sit the fans at an idling speed. So you could maybe set it so they always run at 20%, so they're always just a bit of airflow through, just to keep some airflow running through over the gear. That's always a nice thing to do. But then as the temperature rises, it goes whoops, and it ramps up the performance and starts the fans running at a higher level. So there's we're introducing a little bit of control into our climate control. Now, we also have what's known as a thermoelectric cooler. So this falls into the cooling unit category, but it also is quite unique because this utilizes what's known as a Peltier circuit, which is basically two electrically charged plates. They're oppositely charged, and depending on how that's programmed, it allows this unit to perform either cooling or heating, which is quite interesting. Now, it's only a very small output. It can only work up to about 100 watts, which, isn't a large amount. However, this has a few tricks up its sleeve and is quite useful because it can be operated in both a vertical, as you can see in the picture, but it could also be turned on fully on its side, so 90 degrees, and work in a horizontal. The reason that is interesting to you is because it can be ideal for, say, little command panels or enclosures with very little cooling required. It might just be some switch gear in a room and you just need a little bit. And obviously, if you need a couple of these mounted on a command panel and you've got the room, they can bank together, and then all of a sudden, if you've got three on there, you've got 300 watts worth of cooling. So it's just something to keep in mind, and it's very robust. The operating temperature is pretty good as well. It works down to -30 and up to +55. So it's a nice little Swiss Army knife of a solution. Cooling units for Blue E. So what I've done is now we've moved on to cooling units, but I've split it into our old generation, which is Blue E, and the next slide is on Blue E Plus. Okay, and this will become apparent as I start discussing it. So cooling units now, we're getting into a refrigerant circuit, which works very much how your fridge at home works. So basically we've got a refrigerant circuit in there. So we've got liquid refrigerant in a hermetically sealed tubing, copper tubing, which will now allow us to have a colder internal temperature than the ambient. So if we want to maintain 35 degrees inside the enclosure, but it's 45 degrees outside, if you've sized that cooling unit right, you're living the dream. It's going to be doing it all day, not an issue, because you've got that cooling refrigerant circuit inside this product, okay? You can start to remove larger amounts of heat from the enclosure, and you can start to maintain a tighter internal temperature. And what I mean by that is we want to try and keep the electronics inside your critical equipment in that protected environment. And the less temperature undulation or difference that we can show to the equipment, the longer it will live. Now, we sell a lot of different versions of these cooling units. We have roof mounted versions, we have NEMA rated versions, which are NEMA is used more in America. It's sort of like IP, but it's not as comparable. It's got its own set of parameters, but they are there for if you're doing things across the pond, different projects. We also offer stainless steel variants. And we offer them from very small ones, 300 watts. We also offer up to 4 kilowatts in size. So again, if you've got a large bank or a suite of enclosures with 5 or 6 enclosures banked together, you could put 3 or 4 of these 4 kilowatt cooling units on there, and all of a sudden you've got a fair amount of cooling to be working with when you're installing your new production line. So you can bank these together, and you're going to be winning. So you've got a separate internal air circuit here. So again, we're not allowing dirty air inside the enclosure once the door is shut. It's IP54 rated, and these can operate from +10 up to +55. So that's just a very brief overview of the Blue E range. Now, if we move into Blue E Plus, this is our market leader. We were the first people to bring this to the market. This technology is unrivaled still to this day. It was launched in 2015. I don't apologize for showing off slightly here. It's a jewel in our crown. We like to be very proud of our Blue E Plus range because we work very hard. We have a big R&D department, and we're trying to bring you cutting edge solutions, and here is one for you. So the difference now with Blue E Plus from Blue E is the fact that we're still using that refrigerant circuit, but now we've combined in the same box a heat pipe, or what is really an air-to-air heat exchanger. And what that means to you is the fact now that we're providing demand-based cooling. So in the past, cooling, much like our competitors, was on or it was off. It's much like your thermostat in your house. If it gets cold in your house, your boiler kicks in, turns the radiators on. When it gets hot, they turn off, and you get that sawtooth pattern. It goes up and down and up and down. And as we mentioned before, we don't want to thermally cycle our equipment if we can help it. So the refrigerant circuit in the Blue E Plus cooling units is inverter driven, or the compressor, etc., and the fans are all inverter driven, so we can have infinitesimal modifications of the output. So we can be working at 66% rather than 100%. Things like that. And the other great thing is, as I mentioned, we've got this heat pipe. Now, the heat pipe works like an air-to-air heat exchanger and doesn't require any electricity. So what that means to you is, when it's cold outside, or when it's winter, the unit will go, hang on, it's cold enough outside that I can turn my compressor circuit fully off. I'll just use the heat pipe, and all of a sudden your electricity costs for this unit have plummeted. So that's where we get these 75% energy savings from. And these are tested figures that we have used in the field. We've got sites across the globe where we tested this when we first launched. But this technology is really exciting because this is going to save you a lot of money. And it's not just about the money as well, because if you're saving electric, you're also reducing your CO2 consumption, or your CO2 output, if you like. And again, before Corona came along and took the news headlines, the buzzword for about a month or so was net zero, carbon zero, whatever you want to call it, the reduction of CO2. So again, what you will find is when the world gets back to working normally, hopefully very soon, everybody will jump back into the energy saving mode, and all the restrictions will come in again. It's coming. We know it is. Electric cars, getting rid of diesel, all that sort of thing. Factories are having to be more efficient, less damaging to the environment. And this is a way where you can make big swathes of energy saving and thus reduce your energy footprint. Also on these, we've now implemented quite a large touch screen, which is showing all the data and live alerts. So again, somebody walking past a panel now will catch with their eye when it says door open, or it says, any particular alarm, rather than just it, flashing a little LED or just saying like a code number, and that person might not understand what that means. Another great thing as well, if you're making products that are going to be sent to different places across the world, or you have multiple sites in different countries, these units have what's called multi-voltage capability. So what that basically means is they've been designed with inverters inside, so that, or transformers if you like, one unit can work in all the standard electrical supplies worldwide. So you buy one from us in England, you could ship that to America, plug it straight in, and Bob's your uncle. It's going to work straight off the bat. It's plug and it's play. You're not going to have to mess around when you get on site. You can also do the same thing, send it to Japan, and again, it will work. The reason this is good is because, we've had it before. We've had machine builders who've shipped the wrong part number accidentally halfway across the world before they've received, or they've realized what they've done, and then you've just added 4 weeks onto the the final commissioning of your machine. So again, trying to reduce the complexity for you guys who are our customers, our users. We've also increased the IP rating, so now we're at IP55, and we've also improved the operating range for the temperatures, so we can now go down to -20 and up to +60. And what that means for you is now it's gone past 0 degrees. This cooling unit, these Bluey Plus, can be used outside. They can be used outside with the caveat that they must be protected from direct rain. And you might think, well, I don't need cooling outside, but that is where you might be wrong, because you think a lot of people and a lot of sites might have, say, like big water pumps and things like that in enclosures outside. These pumps, it might be the depths of winter, it might be -10 outside, but believe you me, inside that enclosure, that pump is going full chaff, and it's whacking out 3 kilowatts of heat. That heat needs to be gotten rid of. So put one of these Bluey Plus on, cover it from the rain. It's freezing cold outside, so the heat pipe's going to do all the work and not be costing you any electric. If it needs to, the compressor will kick in and support the heat pipe. It's very clever in that way. But now you've got something that's very energy efficient, very smart, and can work in much more aggressive environments. We also offer all of our wall-mounted variants in stainless steel. So again, if you're working in more maybe of a food and beverage environment or chemical or something where you require stainless steel, that's what you've got. We also have the roof-mounted variant, as you can see at the top of the screen. So that's nice and handy little cassette to put on the top of your enclosure, again, if you've not got much space. And also, we'll mention this a little bit more, but we have the ability of Industry 4.0 functionality. So what you do is you buy an IoT interface, which is a small router sized piece of equipment. It bolts to the back of the cooling unit or on your DIN rail inside your enclosure, and that allows you all of a sudden to plug these cooling units into your building management system, and you get all the alerts, etc., straight to your desk. You'll get it on an email rather than having to walk around with a clipboard as we did in olden days. Now you can get the alert straight to you, and you can nip any issues in the bud. Enclosure heaters. So we've spoken a lot about cooling, frankly, because there's always a lot of cooling to be done. But we also need to make considerations about protecting from low temperatures. Again, these are not too sophisticated. They do a job and they're very important. They help combat condensation. Because again, if we go back to our imaginary pump that's working outside, it might turn off at the weekend, and all of a sudden, the temperature starts to plummet inside the enclosure. And the thing is, pumps, things with liquids inside, you do not want the viscosity of the oils in there to increase and get thicker and then turn the pump on, because it's much like your car. If you turn things on cold, they get damaged. You can damage pumps. They're quite a sensitive machine. So again, putting a nice, well-sized enclosure heater inside to protect from too low a temperature is also as important as cooling. And the great thing is, in the Therm software, you can specify your heating needs as well. It's as simple as putting in lowest temperature it will see, what temperature you want to maintain, and all of a sudden the therm software will tell you what size heater you should specify. So very, very quick and easy to do. The thing about heaters to keep in mind is they do not work on their own. They must be linked or used in conjunction with a thermostat or a hygrostat, because again, they are a dumb piece of equipment and they need to be told when they should turn on and when they should turn off. So when you spec a heater, spec a controller for it, normally a thermostat, okay? These guys are DIN rail mountable, or people like to just place them direct on the base of the enclosure. It's sort of really up to you where you've got space, pick your poison. All I would recommend is obviously give it some clearance to make sure the heat can dissipate inside of the enclosure. And these guys can work in an operating temperature down to -33 and up to +65. So again, they're very robust and they will, they will allow you to protect what we care about, which is your critical equipment. Okay, now we get on to the interesting stuff. This is the hot and heavy stuff now, liquid cooling. So liquid cooling is an air to water heat exchanger. Don't let the name fool you. People look at liquid cooling as a bit of sort of a magic. It's it's a secret, but it's not. It's exactly the same thing. All we're doing is we're linking a large grill, like a heat exchanger, to the front of our enclosure, and then a chiller or a chilled water supply gets plugged in the bottom, as you can see from the diagram. The cold water runs through the coil. The hot air from inside the enclosure blows over the coil. It absorbs all that heat energy and takes it out of the enclosure. And that hot liquid is then taken back to the chiller for cooling again. The thing about liquid cooling is it's a very good way to remove large amounts of heat. So if you're getting into larger installations, liquid is probably something you need to start thinking about. So we offer very small air to water heat exchangers, 300 watts up to 7 kilowatts. So again, they can be banked together and daisy chained. So you can start to do some serious cooling if you really want to. Still, that separate internal air circuit, it's as you can see, it's a very sealed box. You're not getting debris getting inside your enclosure. It's IP55. The operating temperature is, again, it's above freezing, because when you start getting below freezing, that's where it goes into more specialized equipment, more like refrigeration equipment. And then it can work, though, up to +70. So again, these guys can work in those really heavily contaminated and really aggressive environments, because +70 in the ambient, it might be you've decided to mount some equipment right next to a foundry or an oven. This is where liquid cooling would come in handy. We have roof-mounted variants available, and we also have hygienic design variants available, which are more used in the food and beverage industry. So the air-to-water heat exchanger needs to be supplied by something, and that's where the chillers come in. So we also manufacture, very proudly, these are our chillers that are designed and manufactured by Rittal. These are basically a cooling unit in a box. Instead of cooling hot air and blowing it into an enclosure, they're just cooling that tank of water that I referenced in the previous slide. These products, again, can be linked to air-to-water heat exchangers. They can be also linked up to our liquid cooling packages. Now, that's just a fancy name for it's a product that we use on the IT side of our business, and I'll show that in a further slide. And you can also, if you've got some specific machinery, whether it's maybe a spindle for a machine tool, whether that's a lathe or a machining center, or even a laser cutter or a laser welder, or laser tips and things like that need a lot of cooling, need deionized water. We can do that with our chillers. So again, if you're mounting it to a machine or something like that, let us know and we can do a lot of modifications to these guys. Again, we can offer thermal output ranges from 1 kilowatt up to half a megawatt. I said megawatt, so that is a lot of cooling. The good thing about liquid cooling is we have standard packages, but also we can manufacture and change all the options around, really dependent on what you need. So you might need 2 pumps in there, you might need increased connectivity or bigger tanks and blah, blah, blah. You can really pick and choose and create a customized solution if you so wish. I mentioned previously the future, the IoT interface. This is something Rittal's really, again, pioneering with on the cooling, in our industry. So basically, this small little router-sized box links to our Bluey Plus products, so also our chillers. And what it allows you to do is you can either access via the IP address and via a browser and look straight at the cooling unit and see its health and look at all the different it's sort of a live look at how the unit's doing, check all the alarms and things like that. Or if you want to be a bit more efficient with it, you can set the unit up so that it will email you if there's any issues or any alarms or any limits are met or exceeded. So again, it takes the human sort of part out of maintaining these products, because it will tell you when it needs checking, and you can then concentrate on other things. We're just about to do a launch as well, which is quite interesting. If you don't have Bluey Plus on your site, but you're still trying to embrace Industry 4.0 and more automation and more technology, we've now launched an adapter which works with the interface that you can see on your screen and allows you to link your Bluey cooling units into your building management system. So the way we see it is, if you've got Bluey on site and that's working great and you're not interested in upgrading to Bluey Plus, although there is a lot of benefits and I would push you to if you would like to, what you can do is get this adapter and then you can get more bang for your buck out of your existing cooling units. So it's a really exciting way. It's a bit of a gateway into Industry 4.0 for you. So, you can dip your toe in the water and see if you like it. So again, any interest on that, just send us an email. Okay, so industry sector considerations, so specific needs of the industry. So one of the big ones at the moment, that's obviously I alluded to earlier and is in the zeitgeist at the moment, is food and beverage. So it's a rapidly growing industry to meet consumer demand. It grows year on year. We export a ton of food and beverage items all over the world. It's just going to get bigger and bigger every year because we all like to eat more and more. The good thing about food and beverage is they're embracing automation in Industry 4.0. So again, a lot of interest on our IoT interface, a lot of interest on the ways that can reduce energy and reduce the possibility of downtime. And there's obviously a high level of focus due to regulations around hygiene, because obviously we don't want things getting in our food that we wouldn't want to eat. So that's where our hygienic design range of products is really suitable. Our enclosures are designed. This is a topic of its own, something that could really be spoken about on a full webinar, but it's specially designed stainless steel enclosures with angles to prevent dirt and debris getting caught and germs and things like that. They have special seals that can be sprayed down and washed. So it's a lot of design's gone into these, and we really do pioneer this, and we work with a lot of the big boys in food and beverage to design these to meet the needs of the industry. So very, very interesting. However, in certain industries or certain sections of a food and beverage area, you do not wash down. So that would be where we would then recommend stainless steel rather than normal mild steel. So we also have those products as well. So again, it's up to you what you need in that site. Or if you work with a customer who works in food and beverage, mention to them hygienic design. What are you doing for the health and hygiene of your environment? Because believe you me, it's something they get inspected on very regularly. Okay, next one is chemical. So again, I know that's a very catch-all sort of term. There's a broad range of requirements there because it really does depend on which area of the chemical environment you work in, and also what product's been manufactured. I don't know. It depends. However, we tend to, as a generic or a standard, offer stainless steel, because if there's chemical vapors in the air, we need to protect from those because it attacks mild steel. So stainless steel is the first port of call. Next one is we also offer special protective coatings. So our Bluey Plus cooling units, things like that, we can provide you with chemically dipped, where everything has been dipped in a special urethane or a special sort of dipped coating to prevent really aggressive, so like raw diesels and hydrochloric acids in the air attacking the units. And again, that's very important because we want this equipment to last for a long time. We don't want it to just all of a sudden stop working because the chemicals have chewed through the steel. Heavy industry, again, very generic, I know, but it's things like quarries or foundries or things like that. You know, customers' needs and the equipment on site does range very dramatically, but you know, it's sites where there's an aggressive environment, high levels of contamination, there's high ambient temperatures. Steel manufacture is one that comes to mind. This is where there's a big emphasis on the reassure that I mentioned earlier, where we can come to site, we can appraise what you've got, where your equipment is, and you know what improvements you could make. Listen, you know, and you may not believe me, but I truly mean this. When I go to a site, I am not there to sell to you. I'm a product manager. What I want to do is, I'm not in sales. What I want to do is I want to give you the right solution. That right solution might be cheaper than the solution you were planning. And believe you me, that's happened a lot of times. Customers will come in and go, oh, I'm whacking a massive cooling unit on there. And all of a sudden, I'll do a therm calc for them and go, well, hang on. If you put this one on, you're not going to waste energy and you'll actually save more money in the long run. So again, our job is to come to site and give you improvement opportunities and suggestions. And also, we can talk through maintenance contracts and how to keep this stuff running so it pays dividends for you for the next 10 years. So you're not coming back to us in 4 years' time saying, I've mistreated it, it's gone bang, I need a new one. You feel unsatisfied and, you know, you're not getting the performance that you deserve. Okay, so very brief again. I'm going to do a separate webinar on this, but IT infrastructure, it's cooling, but it's in a completely different way. And the reason it's a different way is because IT equipment is what's known as front breathing. So what that really means is if we look at an IT rack from a side profile, it takes cold air in at the front, it goes through the equipment, and then it's blown out the rear as hot air. Okay, so again, completely different to how industrial's done, because industrial is you just fill the enclosure with cold air, it warms up as it rises, and then it's either brought back into the cooling unit or it exits out the top through a fan or a filter. Again, IT racks are very highly dense with equipment, and IT equipment emits a lot of heat. You know, when we're looking at like heat losses, it can be 10 kilowatts with a couple of servers in there. And I'm not joking on that. It can be a lot taller or a lot higher, even on a small rack in like a broom cupboard. So again, IT is a lot more about liquid cooling, a lot larger heat exchange and things like that. So Rittal has a full catalog worth of section just on specific IT cooling equipment. You're probably thinking, well, I don't deal in IT. Why is this something I care about? The reason you should care, and the reason you will start to see this more in the industrial sector, is because industry is embracing more and more automation. Automation, robot arms, you know, your car manufacturing plants, all that sort of good stuff, that creates data. This data needs to be stored or processed somewhere, and where is that? A lot of the time now, it's in an enclosure on the side of the line. So industrial IT, as the term is coined, is becoming more and more prevalent and more something that you're going to have to deal with. So again, we're launching a new product very, very soon. I'll be doing a webinar on that. It's Bluey Plus, but it's for IT. So it's the same product, but it's an IT-centric solution. And this is perfect for those industrial IT applications because you're going to get the nice, robust, high-quality, energy-efficient Bluey Plus, but it's going to be able to look after your more sensitive IT equipment. Okay, we're on the home stretch now, guys. Bear with me. So ensuring correct installation. Small changes when you're installing do make a big difference. Your wiring. If you're covering your electrical components, and again, these are not staged photos, these are photos we've seen over the years. If your wires are covering your electrical components, if you provide inadequate clearance between your cooling unit and your electrical components, or you provide insufficient clearance around the cooling unit on the outside, this is a no-go. This is, you know, you're not going to be having a good day. You're going to be causing the cooling unit to fail, or it's not going to be able to cool your equipment properly, and we go back to all the problems we spoke about previously. So you're sort of biting your nose to spite your face. Service and maintenance. It's too costly to ignore, frankly. It's overlooked. It's something that people, when they're trying to save cash, they'll go, oh, we'll maintain it ourselves. With best will in the world, guys, you guys are busy enough than having to walk around and maintain your own equipment. And maintenance, and again, it's the way I compare it is, go back to cars, you know, car analogy always works. It's comparing between going to the bloke, you know, the garage on the corner where you know the guy, or going to the Ford garage or the Volkswagen garage, that, you know, the people who make the car. You get a different level and a different quality of service because they know the product better, and they can do a higher level of maintenance and keep the car running, or keep the cooling unit running. So things like this, soiled filter mats, not replacing them correctly, you know, letting the unit get into disrepair or dirty on the outside. This is what it starts to look like on the inside. All that rubbish and detritus and debris in the air, it's got to go somewhere. And much like your car, you know, if you let it get a state and your engine starts to get all dirty and crudted up, it starts to affect your performance. So poorly maintained units, what happens is the production line stops, and what does that equal? It equals money lost. Okay. So, you know, we want to try and prevent that, don't we? This is the, you know, basically this is what it boils down to. If your line stops, you're not making money, and also you might be the person that has to go into the meeting the next day, and they say, why did we not get all the bread out yesterday? And you've got to answer the question, oh, well, the cooling unit broke down because we don't maintain them properly. So again, it's a butterfly effect. Looking after your equipment, it will look after you in the long run. Here's an example. Take a dirty ambient environment, okay? We've got years across the bottom, we've got performance level up the side. No servicing, this is the sort of experience you're going to see. It's going to take quite a nice nosedive, and the performance level of your equipment will continue year on year to go down. However, if you organise your friendly neighbourhood Rittal service person to come and give you even an annual service, it might need to be more if it's a really dirty environment. This is the sort of thing you will see. Yes, it's still going to degrade as the products are used, because that's what happens with anything. However, it will degrade at a lot less, a lot slower of a rate, and you will get bang for your buck. They always say about maintenance, you know, the good thing about maintenance, if it's done well, it seems pointless because you don't have any issues, but that's the whole point. You don't want to have issues, and, you know, have to be ringing up, because, you know, it's like the AA. You know, you have membership with the AA because if you break down somewhere and you ring them, they charge you double, because, you know, you're paying out of a contract, whereas if you have a contract, they're very affordable. So on the contract side, again, we have a service department. Our guys cover the whole of the country. To be fair, we have service departments all across the world. So again, if it's going to a site that's not in this country, they could deal with the local country for them. The thing about service contracts is, much like the chillers, they can be specified to suit your needs. You might need 4-hour call out. You might need best endeavors. You might need equipment stored on your site or stored at our site for somebody to quickly come and deploy it, or you might be all right to wait a week. It really depends, so you can really tailor it to suit the needs of your site. Okay, so in conclusion, number one, climate control equipment, select it based on thermal calculations. So use that therm software to make an educated guess, or an educated calculation, sorry, on the climate control equipment you require. Number two, consider your environmental factors. Have a walk around your site, have a think. Do I see high temperatures? You know, does Big Dave take his sweater off every time it gets warm, and, you know, those sort of things? Is the chemicals in the air, is it dirty? Number three, make sure your enclosures are sealed. You know, I've seen it before. People have put cooling units on the side, and then they've just put a bit of cotton wool over the massive holes where the fans and filters used to be. it's not going to cut it. The air's still going to get through cotton wool, I hate to tell you. You know, you need to get those holes covered up and make sure it's a minimum of an IP54 rating for your enclosure. Number 4, install as per manufacturer's instructions. You know, I know what we're like. It's a stereotype. I hate to say it, but you know, you whip the instructions behind your head when you're building IKEA or whatever you're doing. And you think, I'll figure this out. Probably not the best thing to do in this way. And again, if you don't have time or you don't have the guys to spare to install, we can do all that for you as well. We can take your old stuff away. Number 5, maintain a regular service schedule for maximum performance. You know, servicing and maintenance really does pay dividends, believe me. It's better than your line breaking down and then all of a sudden you're waiting 2 days and your orders are stacking up and your customers are ringing, you know, where's my equipment? And all of a sudden you might be paying late fees, things like that. So, you know, keep all that in mind. Okay, so I'd like to thank you all again for coming today. Really good turnout. I'm really happy. I hope you're all not going too insane working from home, or you know, not being able to go out, etc., and social distancing and all that. You know, my name was Carl Isa. If you fancy, you know, come drop me a line on LinkedIn. We're always putting stuff on my personal profile, on the Rittal UK profile. We do a series of videos called Climate Club, where we cover all random topics in the climate control. And, you know, again, if you've got any questions or topics you'd like covering in those videos, let us know. I'm happy to do it. Always like to hit the needs of the customers. Again, any concerns, any comments, any questions, pop them to cooling@rittal.co.uk. If you want some therm labels, send me an email. If you want a copy of the therm questionnaire, send me an email. What I'll do now is, you know, the presentation's complete, but if anybody's got any questions, pop them in the chat or pop them in the questions section. I'll see if I can figure out how it works and I will answer those questions. So thank you very much. Okay, so somebody has asked if we're going to get a copy of the presentation. I believe it's being recorded now, so what we will probably do is we can send you out a copy of the presentation, and we might also send you out a recording of the presentation. So yeah, we'll get that sent out to you after the fact. Okay, somebody has asked here, is the watt losses of the cooling unit itself expelled, or does it contribute to the internal heat rise? That's a great question. No, all heat sort of generated, if you like, by the cooling unit, that is emitted into the ambient air. So that's when you're using a cooling unit. However, if you're using, you know, if you don't want that because it will attribute to warming up your environment, if you don't want that, I would recommend looking down the liquid cooling route, because then what will happen is the hot water will go back to the chiller, which you might even have outside, and then it's all emitted into the, you know, the external outside of your workspace. Do I need to fit a water port to the thermoelectric cooler? No, you do not. The thermoelectric cooler does not use water or any refrigerant or anything like that. It uses 2 electrical plates. So all it needs is electrical supply. Somebody has asked for Blue E Plus, what is the scenario which the 75% energy savings are measured? We actually measured against our own Blue E cooling units. So we didn't measure against competitor because, to be fair, we actually in some instances saw even better savings. We compared against ourselves. So we went to existing Rittal sites, and from there we had, say, 2 machines, one with Blue E on, one with Blue E Plus, and did a comparison over a long period of time. If somebody has mentioned that they already have a chiller in use next to their enclosure, that's great. If you've already got a chiller on site, what you can then do is just specify the right sized air to water heat exchanger. That heat exchanger can then be piped and connected to your existing chiller, obviously only if your chiller is big enough. But again, we can help you with that. So if you have a specific application, please drop us an email. Somebody has said, do you have more information on the layout of equipment installed inside a cabinet to maximize climate control? Now, I would recommend checking out our sister company, ePlan, because ePlan sort of produce a software which allows you to digitally basically create a digital twin and design the layouts of your cabinets before you even start to build them. So that's a really good software tool. So if you're building a lot of enclosures, that's a really good way, because it will show you whether things are laid out in the wrong way or they're not going to get the right sort of level of cooling. However, if you've already got an existing cooling sort of enclosure that needs cooling, the best thing I can say to you is it is very hard, because obviously each enclosure is its own sort of rule. What I would recommend is look inside and think, right, have I got large drives that are jutting out and blocking air being blown around the enclosure? Or have I got particular sections that are getting really hot, or certain bits of equipment that always say at the top of the cabinet that are getting hot and clicking out, but it's nice and cold at the bottom? If so, that might be that you have to get some ducting or some sort of baffle plate, which then pushes the cold air where it needs to get to. But again, what I would recommend on something like that is very much not a straightforward answer. I would recommend contacting your local Rittal representative, and we can come on site, do a free look around, and we can give you some of our knowledge and say whether we think things might be jigged around or whether there's improvements that can be made. What is the theory behind the 35-degree magic number? Now, I don't know the answer to that question. All I know is the DIN standard that we work to and we design and test our equipment to, it denotes we do tests at 2 points. We do them at 35 degrees set point internally, 35 degrees ambient, and then you also do 35 degrees internal with a 50-degree ambient. So we test all of our equipment at those parameters, as do all of our competitors, because that's the DIN standard that we work to. I believe what I've been told from colleagues in Germany at HQ, etc., is 35 degrees is your magic number between wasting too much energy on cooling and also not allowing the equipment to get too hot and then start to degrade. Now, have a look at the drives that you use. You will find that a lot of them now are being designed to work sort of up to like 40 degrees, some even higher, because people are realizing that, enclosures are getting hotter and hotter. But what I would recommend is that 35 degrees is a great balance between the two. Do the thermal calculations allow for an internal temperature of 20 degrees C for fitting batteries within the racks? Great question, because obviously batteries are a very sensitive thing, and the hotter they get, the lifespan rapidly dies off. Yes, you can pull the ambient temperature down in the Therm software. I believe the lowest it can go off the top of my head is 21 degrees C. So what I would recommend is having a look on Therm and having a play around. I think its lowest you can go is 21. And again, what I would recommend is, this has come from Julian, what I would recommend, Julian, is you might want to contact us on that, because we do a lot with people who are doing batteries, and you might suit the IT cooling equipment more than the industrial equipment, depending on how you're storing, if it's going in 19-inch racking, etc. So it's worth looking at that in more detail. We can give you some advice. Hopefully that's useful. Dumb question, but just to confirm that for a straightforward fan and filter system, the fan goes at the bottom, sucking in clean air through a filter. That is correct. Yes, the reason we tend to recommend putting the fan at the bottom is because air is colder near the floor because of convection. It obviously gets hotter as it goes higher. So that is what, as Rittal, we recommend. However, our fan units, literally, you can unclick them without any fasteners and spin them 180 degrees and then click them back in place, and then they will suck or they will push. So if you decide, no, I don't agree with that and I want to put the fan at the top, pushing air out of the enclosure rather than sucking air in, you can do it, but we wouldn't recommend it. And the reason we don't recommend it is because if you put the fan at the top sucking, what happens is it creates what happens is the air comes in and there's like a path of least resistance, and the air then will, instead of being thrown into the enclosure and hitting the equipment, it will sneak up the inside of the door as the path of least resistance and then sneak out the top. So you won't tend to see as improved cooling performance. What's your thoughts for protecting enclosures inside a climatic chamber with 40 degrees to 50 degrees temps up to 60 degrees humidity? Yeah, this is something we can do. Again, if it's up to 50 degrees, a Bluey Plus cooling unit can go up to 55 degrees. And again, 60 degrees humidity is fine. We see higher humidities than that, obviously, when things are shipped abroad. So all we tend to say is, as a rule of thumb, if it gets into high humidities and it's prolonged high humidities, we might recommend stainless steel as a bit of belt and braces. But again, Eddie, if you've got a specific inquiry, drop an email to cooling@rittal.co.uk and we can talk about it in a bit more detail. And the final question I've got is, what is the email for the temperature stickers again, please? And I hope nobody's taking the mick there, because I've said it quite a few times through the presentation. But the answer there is just drop an email to cooling@rittal.co.uk, as you can see on your screen. We'll be happy to get that sorted for you. Again, if you know your local Rittal area sales manager, give them a call and they can sort it as well, whichever's easiest for you. So I don't have any more questions at this time. I hope I've answered everybody's questions. If not, drop me a line. Thank you all for coming, really appreciate it. Hope you're all well and keeping well. And yeah, I'll see you at the next one. We're doing a lot more webinars over the next few months. So get yourself on and give the other product managers the support, and hopefully you'll learn a lot as well. So thanks, guys.